Today we're going to talk about seafloor spreading, and our focus question is what happens at deep ocean trenches. First, let's start with talking about the theory of plate tectonics. It's the theory that the outer ridge layer of the Earth, or the lithosphere, is divided into a couple of dozen plates that move around across the Earth's surface relative to each other, like slabs of ice on a lake. So you'll see the plates right here. And they don't match up with what the actual continents are because they're lithosphere plates and they contain both oceanic and continental crust. So what is seafloor spreading? The seafloor spreads apart along both sides of the mid-ocean ridge as new crust is added. So you'll notice in this picture, the lithosphere, the actual crust layers start to move apart from each other while magma flows up, and within this mid-ocean ridge, new crust is formed. One of the largest ones that you'll hear about is this mid-Atlantic ridge going in between South North America and Africa and Europe and Asia. So for the formation of them, these occur at divergent boundaries, and new ocean crust is formed, like we said, and a ridge is present. So this magma leaks up from the asthenosphere. Once it cools, it adds new crust. So continental drift. We talked about continental drift on Friday, and this is a theory that explains how continents shift position on the Earth's surface. It also explains why lookalike animals and plant fossils and similar rock formations are found on different continents. So just like before we had talked about, 200 million years ago, there was one large landmass, or almost one large landmass, to 130 million years ago, where they slowly start to move away from each other. And these arrows kind of show the direction in which they're moving, all the way up into today's, where they continue to move based on new crust being added to the ridges. Subduction at the trenches. So there's also something that occurs at convergent boundaries, and it's called subduction. This is a process in which the ocean floor sinks beneath the deep ocean trench and back into the mantle. So oceanic crust, being more dense than the continental, slides underneath the continental crust, and you have this subduction zone down here. And it creates this trench right here where there is a meeting of the two types of crust. As this part of this oceanic crust slides underneath, it goes back into the mantle and the rock will melt back into the mantle. This will start to move faster as the longer this piece is right here because it pulls it or sucks it in. This can also cause cracks in the lithosphere, and then magma can leak up, and this is what can create these volcanoes. So which is more dense, oceanic crust or continental crust? Which is more dense, the crust or the inner core? Which is more dense, the mantle or the outer core? Where do convection currents occur? And at what type of boundary do trenches form? What occurs where oceanic crust meets the continental crust? What is the theory that explains how continents shift on the Earth's surface? That's all for today. Go ahead and move on to the rest of your playlist. And when you're done with that, you may use some of the review games listed on the website.